All right, today's lesson is oh my God, I can't say that.
Logarithmic
Thank
functions.
you. Logarithmic functions. Oh boy. So our essential question today is how can I write equivalent forms for exponential and logarithmic functions? Miss Young was practicing writing.
Yes, the writing is not the neatest. It's
That's
my
okay.
writing. That's okay. So have you ever wondered how many times would you have to double a dollar before you had $8? That's math we can do in our head.
Right.
We use the formula 2 to the x equals 8. And again, the key word double. When you hear the word double, you're going to be talking exponential. We talked about that in the last lesson. So you would have to double a dollar 3 times to have $8. Because if you double a dollar, right, doubling a dollar gives you 2, and then 2 times 2 times 2 is 8.
Got it.
Now, if I ask the same question, how many times would you have to double a dollar before you had $512? That you
I can't do that in my head.
No, you could do it the same way, but it would take a long time. So then we have the inverse operation. So the inverse operation of exponential is logarithmic.
Okay.
So that's what we're going to do today. We're going to change an exponential equation to a logarithmic equation and vice versa.
We're just going to say a log equation.
I like that way better. So one thing that's so important that I'm going to emphasize, and Miss Boyd, all the time is a logarithm is the exponent to which a specified base is raised.
Okay.
So all the time, I want you guys to remember log equals exponent.
Got it.
So now if you look down below, it shows how we go back and forth. Exponential equation, b to the x equals a, or the log form is log base b of a equals x.
So the only thing we're adding is log, and then we're just switching where these things
Right.
go.
So notice over on the right, log equals exponent, just like I said up there. So that's how you know, that's a quick way to remembering where the x goes if you say log equals exponent. So the base becomes the base for the log, the a becomes the a for the log, and then the exponent is on the right side of the log.
Okay.
I want to also emphasize that b can never equal 1.
No.
And it always has to be greater than 0.
Gotcha. So no decimals,
Nope.
no fractions. Got it.
Okay, so, well,
No fractions less than 1.
right.
Yes.
Exactly. Okay. No fractions less than 0.
Less than 0. Sorry.
Yeah, okay.
Whew.
Next page. Let's see.
Yeah.
Here we go. Boom. So let's do this.
Okay.
You're honestly going to think this is really easy. So let's go through these. So we're going to go from exponential. So we're going to write the word log, and our base is going to be 2.
Can I quick jump?
Oh, goodness, you do whatever you want.
We said the exponent always equals the log, so I'm going to just write that one right away.
I like that.
So exponent goes there.
Perfect.
Now,
The
this
base
is
the little
so it goes
number.
Bottom.
That's a base.
then
And
the
what's left is
64
what we didn't use.
goes right here.
And I like the order that Miss Boyd did that in. I think it's great. Okay, let's do the next one.
All right,
So
so again,
log.
log. What is our exponent?
1.
Equals 1. Here's our base. So
Yep.
it goes to the bottom.
Right?
And then 4.
Right.
Is what's left over.
Exactly. And
These
again,
are easy.
aren't they easy?
Log
Equals
0.
Yep.
5 is our base. Our number
And
left
1.
over.
Perfect. And log
equals negative 2.
2.
Our base is 5. Our number left over is
0.04. Perfect.
And log,
Mm-hmm.
it equals this time, it just equals x,
X.
which is fine.
Our base is
Base is
3. And
Big number is
yep.
81.
So notice how Miss Boyd is writing this. On the log, the base is the little number that goes a little lower. And then the big number 81 is
Stays up top.
and it's like right next to the word log.
Got it.
Okay, let's go the other direction. Let's convert from log to exponential.
Okay. So I'm going to start with base.
Yes.
Base is 10.
Definitely. Exponent.
Our exponent is there.
Yep. And that
And then it equals our big number here.
Right.
100.
Exactly.
Which makes sense. 10 squared is 100.
Right.
All right. So our base is 7. Our exponent is 2.
Right.
So it equals
49.
That makes sense.
Yep.
Our base is
Is
8.
8.
Our exponent is
Negative
-1.
1.
So it's going to equal 0.125.
Correct.
Our base is 5. Our exponent is 1.
1.
And that's equaling 5.
Yep.
That makes sense.
Our base is 12.
Exponent is 0.
And that equals 1.
Makes
Perfect.
sense.
All right. Pretty darn easy.
Yeah.
Okay, so now we go to the next page. A logarithm, we talked about this again. A log is an exponent. So the rules for exponents also apply to logs.
Oh.
You may have noticed the following properties in the last example. Well, let's go through this and see.
Okay.
So the properties are, notice, when the base b is equal to that value of the a value, when they're the same.
Oh, okay.
Okay.
So B is B here.
Yep, see that?
Gotcha.
Then that
Base to
log
one.
is equal to 1.
That makes sense.
Which makes sense
The
because
base to
b
any
to the
one
1
part
is
is
equal to b,
itself.
right? And the logarithm, let's see, the next property just says when you're taking the log of a base b and the a value is 1, that's always going to be 0, which makes sense because if
So
you take
exponent
b,
of anything,
you
is
raise it
one.
to a 0, you're going to get 1.
Got it.
All right, next part. A log with base 10 is called a common log. So when you have the word log written and there is no base written, it is
You just
assumed to
assume
be
it's
a 10.
So
And
we
you
would just assume
right.
that's a 10.
Miss Boyd's writing it. You
don't
don't
make
have
it.
to, but it's okay. If you like it, you can write it.
Okay.
So let's go on to example 3. And what it says to do is it says use mental math.
Okay.
So
So
the-
don't pull your calculators out.
No. So the first thing you're going to do, I see the word log. We're
I'm
going to
just gonna write
change
this in.
it.
Is that
I would.
good?
Definitely, I would.
Okay.
Could you write also a note somewhere
Sure.
to the right or somewhere, anywhere? Change to exponential. Because that's exactly what we have to do to solve this. When you have a log and you're
Okay.
evaluating it, you change to exponential.
So that's why I put the base in, because it'll be easier.
Yep,
So we
I
got
would too. 10
to
to
the
the
x
x is
equals
0.01.
0.01.
Right. Now, we have a decimal.
Mhm.
That's kind of hard. So let's change the decimal to a fraction. So that's
Oh.
the same thing as 0.01. And you can use your calculator if you need
Well,
to.
it's tens,
Right,
hundreds.
that's it. So it's 1 over 100. And that's equal to 10 to the x. Well, now I think we can do this, right?
Yeah, because this is a fraction now, so it's going to be a negative exponent.
It's going to be negative because it's taking the reciprocal.
And we have
Right.
one spot.
So 10 to the negative 2.
2. Yep, because there's two
Yep,
zeros.
that's the
total.
same thing as 1
Gotcha.
over 100, right? So really, the answer we're trying to find is what's x? So x is equal to,
Negative 2.
yep, and that's what we're finding. Yep. Excellent. All right, let's go on to the next page. And we have example 4. Let's just see. And then we have example 5. We're not gonna do all of these. So let's see my mouse. Whoa, we're just jumping all over the place here. Okay, how about we're here, let's just do
this
it
one.
because I'm struggling.
All right, our base is 5.
Yes, so we change it to
Our
exponential.
exponent is x.
Yep.
Equals 125. So
Exactly.
we ask ourselves, what 5 to the what power gives us 125? 3.
X is equal to
X
3.
equals 3.
You're
That's
done.
Easy.
That was really easy.
Phew.
So remember, whenever you're solving a log equation, you change it to exponential.
All right.
Now that, I'm just gonna flip forward. Do you wanna save
Yeah,
that,
let's
that
save
one for
one for
class?
class,
Okay.
yeah.
So the video question is, write each exponential equation in log form. Well, not each, there's just one.
Right.
So pick which one it is, and then write that log equation in exponential form.
Easy enough.
Pretty darn easy. We
Okay.
will see you tomorrow.
Bye.